Hello everyone, my name is Mayur Ubale. I am Assistant Professor in Civil Department WIT Solapur. Today we are going to analyze a pH parameter in water. So what are the learning outcomes about this session? At the end of this session, students will be able to analyze the pH parameter in water. So we will discuss various problems regarding pH parameter in the water. So the first question is calculate the pH value of HNO3 solution containing 0.315 gram acid in 200 ml of solution. So as we know, the pH is having a formula that is minus log of H plus concentration ions. But before that, when we are reaching towards calculating how many concentration of H plus ions are there, we have to understand the concentration of H plus ions to be calculated using moles. So generally the molarity is the parameter which gives the value of concentration of H plus ions, and for that the formula of molarity is moles divided by volume of sample, and to do that we have to calculate moles first. So moles of HNO3, which is having a formula of weight divided by molecular weight. So weight of HNO3 is given to us, that is 0.315 gram divided by molecular weight. So to calculate the molecular weight, we know the atomic weight of H, that is 1, atomic weight of nitrogen, that is N, which is 14, plus 3 times atomic weight of oxygen, which is 16, because see, in the formula of HNO3 3 times the oxygen is there. So by which you will get the molecular weight of HNO3, which is 63. So by dividing we will get the value 0.005. Now concentration of H plus ions is having a formula of moles divided by volume of sample, which is in liters. So we have calculated moles earlier divided by volume of sample, which is 200 ml, we have to take in liters. So it will become 0.2 liters. So 0.005 divided by 0.2, which is coming about 0.025 molar. Now put this value into the basic formula of pH, which is pH will be equal to minus log of H plus ions concentration, which is 0.025 molarity, which is coming about 1.602. So this is the pH of the HNO3, which is the answer of our question. As it was very simple, let us have some tricky question. The second question is, what is the pH value of 0.05 molar H2SO4 solution? Here the molar value is already given to us. We can directly put into the formula of pH and find out the value of pH, but understand the concentration is very much lower, it is very much dilute. It means when the H2SO4 is coming into the water, it forms 2H plus and SO4 minus, which is dissociation of H2SO4 will happen. Now here in the formula you can see 1 mole of H2SO4 is producing 2 moles of hydrogen, and in the formula it is minus log of H plus ions, not the concentration of that acid. So first we have to calculate the concentration of H plus ions. As we know 1 mole is producing 2 mole, so 0.05 molarity, as the molarity is directly proportional to moles, so we can say 0.05 moles of H2SO4 is producing how many moles of H plus ions, or concentration, which is in molarity. So it will form 0.05 multiplied by 2, because it is producing 2 moles of H plus ions per 1 mole. So it is coming about 0.1 moles. As it is directly proportional and your denominator is not changing, that is volume of sample, so concentration value would remain the same. And putting this value, that is 0.1, into the formula, which is pH is equal to minus log of 0.1 or 0.05 multiplied by 2, you will get the value of 1. So pH of 0.05 molar H2SO4 solution is 1. Let us have some more difficult question. Question 3 says, what is the pH of 2 into 10 raised to minus 8 molar HCl solution? Again, it is very dilute. Now, when this uh, solution is coming into the water, the H plus ions concentration of HCl would be there, but additionally the H plus ion concentration of water would also be there because the solution is very dilute. So effect of H plus ions concentration of water would also be adding into the pH. So H plus ions concentration of water for a neutral pH is generally 7. So in concentration it forms 10 raised to minus 7 plus 2 times, because 2 multiplied by 10 raised to minus 8 is there. So I am keeping it same, 2 times 10 raised to minus 8. By adding so, you will get the value as 12 into 10 raised to minus 8, which is our main H plus ions concentration. Put that into a basic formula of pH, that is pH is equal to minus log of 12 into 10 raised to minus 18, by which we will get the value of 6.92. We will have a relatively more difficult question now. The fourth question says, when equal volumes of pH which is 4 and pH which is 6 are mixed together, what will be the pH of resulting solution? So we cannot average it out because the formula is having log in it. Now to do that, we have to go into fundamentals again. As the concentration of H plus ions is coming from moles divided by the volume of sample, and here it is saying the volume is same for both. So let us focus on moles. How many moles of one solution which is having pH 4 is mixed together with how many moles of water which is having a pH 6? So calculate the moles first, and for that we will use the formula of molarity. So molarity is number of moles divided by volume. Now understand, as the pH is 4, it means it is having a concentration of H plus ions to be 10 raised to minus 4, and similarly for pH 6 it is 10 raised to minus 6 molarity. So concentration is known to us, that is molarity is known to us, and volume is also known to us. We have to calculate the moles, and for that we would say, firstly let the volume of one sample to be V, that is capital V, and it would be remain same for both. Now to calculate number of moles, we can say molarity multiplied by volume. I am just readjusting now. So I know the molarity from upper part, I know the volume which I have considered to be V. Just cross multiplying, I will get number of moles for sample 1, that is N1, to be 10 raised to minus 4 multiplied by V, that is 10 raised to minus 4 multiplied by V. Similarly for sample 2, that is N2, 10 raised to minus 6, that is concentration of H plus ions over molarity multiplied by volume, that is capital V. So I know number of moles. Now understand, when I am adding these two samples, automatically the moles are also getting added. For suppose sample 1 is having X moles and sample 2 is having Y moles. So total moles of the solution would remain X plus Y. So similarly, the total number of moles after mixing would be forming 10 raised to minus 4 multiplied by V plus 10 raised to minus 6 multiplied by V, which we had did it earlier. Now to calculate the total molarity of the solution, that is addition of sample A and sample B or N1 and N2, total number of moles would divided by total volume of the solution. So total moles which we had calculated earlier, and total volume, as equal volumes were there and two samples were added, it forms V plus V, that is 2V. And by doing so and putting into the formula, I will directly get the value of pH, that is 4.3, because V all will get cancelled and it will form 10 raised to minus 4 plus 10 raised to minus 6 divided by 2, and by that I will get the value to be 4.3. So in this way we have to calculate. If I go back, you can see, if I did it arithmetically, that is 4 plus 6 divided by 2, the value would come 5. But what is the correct answer? It is 4.3. Now let us have few review questions. First, if a solution has a high pH, it has a low H plus ions concentration. Second, if the pH of solution changes from 6 to 4, how does hydrogen ion concentration change? And the last one, the pH of rainfall water is typically what? It is a general knowledge question. So let us have its review answers. Yes, if the solution has high pH, automatically the H plus ions concentrations reduces down. If the pH of solution changes from 6 to 4, automatically your H plus ions concentration must increase. Now putting into the formula which we had solved it earlier, you will get the answer to be it can increase by 100 times. And generally the pH of rainfall water is typically 5.6. These are the references I have used to make this session. Thank you so much.